Hello, I bought a second one of these Texumos a while ago. I really liked the first Texumo I had, and what I was going to do with this one was make a so-called blunt-nosed build where instead of gluing the wings together directly at the middle, you make a middle section out of, I was thinking to use something like plywood with a carbon spar, and inside that section you put your battery and your camera and stuff. It just makes it a bit easier to mount stuff, especially when you're putting all these cameras all over the front of it. For FPV, you want the front of it to be stronger instead of a pointy little triangle that keeps getting broken and bent. So I had this sitting around for a while and I hadn't really gotten around to building it, and then a little while ago my pusher at Banggood asked me if I wanted to review this plane here, and this looks very interesting. So I put the brakes on my Texumo project. Well, it wasn't going anywhere anyway, but I put that aside for the time being, and I've just got this a couple of days ago and I've built it out and it is ready to fly, but the weather's looking a bit bad at the moment. So this was very interesting to me, obviously, because it's basically the blunt nose thing like I was planning to build anyway, except it's much more sleeker and professionally done. So you can see the pics of it there, and I'll put a link in the description. These instructions here are in the kit as well. This is the plug and play kit, so it includes quite a lot of stuff, including an FPV camera and transmitter. Pretty standard stuff, especially the camera doesn't look too flash, but still it's pretty good that you could get that for what looks like it's going to be 130 bucks, the normal price, when it's, you know, after it's finished its initial promotion time. So you get a 200 milliwatt transmitter. Oh, and a 3-axis flight stabilizer as well, which they don't really make a big deal of mentioning here. I think they should probably mention it a bit more. So all you need is a radio and a battery, and there are a few other little bits and pieces like little bits of wire and heat shrink that I needed. And I have not finished making it an FPV capable plane yet. I have not done that, but by the time I've done that I think I'm going to need a little bit more wire and heat shrink as well. So it's not, you don't get exactly everything you need, but it's pretty good for this price. When the plane arrived, I took some photos while I was unpacking it, so I'm just going to go through those now, and I'm going to go through them very quickly. You can pause the video if you want to look at them, because I'm going to cover everything in detail later on, so I'll just go through as if I think of something I'll say something at the time. It was better packed than the mini Talon that I got recently. You could shake the box and it didn't really feel like anything was loose, except when you took these two wings out of the top, it was actually loose inside. Lots of stuff in this kit. You actually get 4 props there. 60-45 bullnose. This is the camera, pretty boring looking camera. Fuselage. This piece slots in to completely fill that gap. I don't think you could really use that though, because you need the CG quite a bit further forward than that would let you do. Winglets, carbon spars, quite a few of them. Big bunch of electronics in that little corner box. This is a 5 volt voltage regulator. This is the stuff that was in that corner box. This being the corner box I'm talking about here. So just in this little corner box there was all of that stuff. Oh, some of that stuff anyway. This is the gyro stabilizer thingy. More bits and pieces. So there we go. I think that's everything. It's quite a lot in the box when you unpack it. This is the fuselage. Wings. Spars and the elevons. It's a not quite neutral, but it's looks to me like it's quite close to neutral section on the wing. These bits here, I realised later, you just cut these off, so anything with this big bobby circle thing on it is to be removed, and these pieces, once they're separated, go into these areas in the bottom of the wing like that and like that. Top of the wing. The battery bay, this is a 3S 1.3, no problems. 3S 1.4, 3S 2.2 was also okay. This is a 4S battery here, and at the time as I took this photo, it fit in okay, but you need to put a piece of plywood underneath here to strengthen this section, and once you've put that plywood in, then the 4S battery doesn't really fit in anymore. You could probably fit it in at a bit of a squeeze if you wanted to remove some material somewhere else, but it's pretty tight. This is the Xiaomi Yi, which I'll be using with it, and you can see it's on a bit of a slant here because the lens piece is bumping into the foam at the bottom, so I removed a little bit of this foam to get it to sit down flat. But apart from that, it fits in very nicely, and there's about 1 millimeter of space front to back for it to move just a tiny bit. And that's the specs of the servos, and that's all the photos. Now, as far as what material this is made of, when I first took it out of the box, I thought, oh, it's actually EPO, even though the listing said EPP. But when I sort of squeezed it and poked at it a bit more, I think it is EPP, but it's sort of a cross between the kind of EPP that you find in the Bonsai and the Texumo, that kind of EPP, and EPO. This is the top of my ready-made RC Mako, which I'm going to give a little squeeze in a minute to compare them to. But I think it has the good points of each. Firstly, it's very, very hard when you try and press it, unlike this EPP, which is very soft. And yet, when you do manage to squeeze it, like this little bit here is a little bit easier to squeeze, it has the elasticity of this EPP. It sort of feels a bit more rubbery, and as you release the pressure, you feel it sort of pushing back on your fingers. You probably can't see it very well in the video, but when you let go, you can feel it sort of returning to the shape that it had before. And this foam seems to do that quite a bit better. Or maybe you can see it in the video. You sort of see it returning reasonably well. I'm squeezing it quite hard there. But it returns to its shape fairly well versus regular EPO, which if I squeeze that, it sort of stays more squeezed. These are similar thicknesses of material here that I'm trying to compare. So that's really nice, and I don't know how the weight compares, but it feels like there's nothing there almost. So yeah, this material is quite nice. The best of both worlds, I think. It looks like some of these magnets were not really too well glued in. There's supposed to be two at the back there as well, and you can see there's some kind of a soft glue that they've used to glue them in. It hasn't worked very well because the magnets have very easily pulled out. I guess it's nice that they're strong magnets though, isn't it? So I think I'll have to glue those back in, probably with Gorilla Glue, and hopefully that will hold better than whatever glue they've used there. This little cavity on the bottom is for the ESC, and it has this little plate that goes over the top there. There's one screw thread been glued in there. It looks like there's supposed to be another two at the back because there's holes in there on the plate which fits in there very nicely, but yeah, a couple of threaded bits missing there, so I'm not sure how I'm going to attach that properly. Here's the cavity on the bottom of the wing where you put your video transmitter or your receiver, and this carbon fiber plate fits in there just perfectly, so they've been quite well made. The included video transmitter has one of these right angle connectors on it, so it looks like if you want to use this VTX, you're going to have it on this side of the wing, which is the left wing, yeah. And it doesn't quite fit in there. It's not quite long enough to get in there easily, but I think if I cut that bit of heat shrink away, it might just fit in there. It's going to be on a little bit of an angle, but it should be okay. Compared to most of the other planes I've had, the amount of material that they've left in the aileron join there, the hinge part, there's actually quite a lot of material left in there, and it makes this very, very stiff. Like, you can just about hold the whole wing in it, like, you know, shake the wing like this, holding the aileron, and it doesn't even bend very much. So I found that what I had to do is spend quite a lot of time bending that back. I haven't done this one yet, but over here I've done this one, and took quite a while, about almost 10 minutes of doing this to get it to come up nice and you know, easy to bend. And I also ran the back of a steel, like what have I got, like something like this, bend it all the way back, and then squash down the bits that stick up, and it makes it look pretty horrible once you've done that. Man, this stuff is really hard to focus on, isn't it, camera? Well, trust me, it doesn't look very pretty now, but it does bend a lot easier, and I think the servo will be able to handle this now. I guess the nice point about that though is that even after you've done that, you're left with quite a strong join. So I don't think we're going to see any breakages along this hinge point like I have had on a lot of my other EPO planes. They tend to break here quite easily, but this one should be pretty sturdy in that respect. The servos fit into their cavities on the top of the wing fairly well. There's a fair bit more play than I would have expected in this hole, but nothing that a bit of glue can't handle, I would think. The servo connector thingy that you get is one of these ones with a sort of a zip tie piece that goes on the reverse side of the elevon. There's no holes or any markings for where you should put that, so you just have to make your own. And over here we have these. They're quite thick, by the way. These, they're not the floppy ones that you get with the DW hobby kits. And then we've got these to attach the push rods to the servo itself, by the looks of it. Not exactly sure how that's supposed to work. So I guess what you're supposed to do here is obviously the screw goes onto the push rod like that, and then you probably have to make these holes in the servo horn a little bit larger because they're all too small to fit that screw through. Can you see that? Yeah, way too small. So you're either going to have to drill those holes out to be big enough to fit that screw, or at this end you're going to have to put it on this end. These holes are bigger than the holes in the servo horn, but they're also too small for that screw. So either way you're going to have to do a little bit of drilling, I think, to get it to work. I drilled out one of the servo horn holes to 2mm, that's the size of that thread there, to see how this worked. And it turns out to be a pretty good idea because you can see the one on the right there, the screw is fully tightened, so this nut's not going to slide along the push rod at all. And it leaves you with just enough space for the servo push rod to have room to rotate. So it's nice and loose, but it's not floppy sideways. Oh, there's a little bit of sideways movement, but not much. So that's a pretty good idea, I think. All the spars fit in really nicely. I've got the two main ones in there, slid in there just quite easily. This one presses in, goes pretty much all the way down the wing, so that's nice. And it's a 3mm one. And then there's this slightly smaller 2.5mm one that goes in the elevons. This one here I'm a little bit concerned about the fact that my what do you call these things? These things are going to have to go right about there where that spar is. If you want to leave the spar there, you're going to have to put them pretty much right in the middle of the elevon like that, which is not really ideal. So I'm thinking I might just cut this spar at that point there. Maybe leave a little bit of the spar on each side of it, but just have it so that this can go right at that point where the spar is and not get in the way of anything. This main section has been designed quite nicely regarding the spars because they come in just outside the battery bay, which is nice because you're not going to have a spar running through the middle of everything. And this one at the front doesn't really seem necessary as far as supporting the wing and the overall structure of the plane goes. But I think probably what this is mainly here for is to strengthen this section here where you're going to have the battery right behind this wall, and then you're going to have your cameras right in front of it. And this is where you're going to be, you know, hitting things. So I think it's quite good to have this spar as well for that section. The spars that they've got here are quite nice. They're 6mm pull-truded carbon fibre, so they're actually better than the spars that you get in the Texumo kit. The back of the fuselage section just has this flat area for mounting the motor, and they've given you this plywood laser cut piece which goes on there, and you are supposed to glue that down. And there are a few quite large holes in it which are not made for threading screws through. They're actually for the head of the screw of this piece. So there's two carbon fibre plates here separated by looks like about 10mm spaces, nicely knurled standoffs, and you can choose either to use those standoffs to put the motor a little bit further back for the CG to be further to the rear, or you can do away with them and just mount your motor directly to this larger carbon fibre plate using the four holes more towards the middle. So that's what these larger holes in the center would be 4. But I'm not going to do that because that means that it's going to be impossible to get the motor off and change it for a different motor. So I'm going to use both of these carbon fiber plates, and in that case you can see the screw heads are on the outside, so you'd be putting those into the outer of the holes there like this, so they fit on there like that. Oh, can't see it, too dark. Yeah, there we go. So they all fit on there quite nicely. And the nice thing about this is now that it's going to be very easy to change the motor, because you just need to undo these 4 screws, and then this whole cross section will lift off and you can get at the motor screws from the back. So I think that's a pretty good idea, and given that I'm probably going to put as big a battery as I can in here and have the cameras, both cameras, pretty much all the time I'll have them in there, I don't think using this extra spacer to put the CG a little bit further back for the motor I don't think that will be a problem. These 2 smaller carbon fiber plates that are in the kit are supposedly for the front of this here, so you're going to, according to the instructions, a little bit vague, but I gather you're supposed to glue one of them across there like that to match up with this sort of a hole cavity behind it, and then in the front side there's another similar cavity where you would put the smaller one to glue over there. And I think the idea of that is that it gives you somewhere to put a Velcro strap to strap in your GoPro, but I don't think I'm going to do that, because firstly I don't think the glue would hold it in very well in a crash anyway, and it also means that for this I'm actually using a Xiaomi Yi, and it's possibly a little bit fatter than a GoPro, because by the time I put those plates in there I'm not going to have much room to fit this in, so I'm going to have to come up with some other way of holding this in there, I think. This piece here seems to be an exact constructive solid geometry subtraction of this cavity here, if you know what I mean. So this cavity and this block are going to exactly match each other, which means that you can't put your camera in here and then put the block on as a cover for it somehow, even though it kind of looks like in the Banggood listing they've done that, although you can't see if they have an HD cam in there, but it does look like they have an FPV camera on this side, so maybe they just cut some away for that. For the FPV cam it might not be so bad, but if you want to put your GoPro in there and cut away enough of this to fit around it, you're going to be left with almost nothing really. It's just going to be a very, very tiny little bit here, and then maybe a thin cover over the top. So I don't think it's really worth cutting this in any way to try and fit it around and use it as a cover. Okay, let's have a look at the electronics that you get with this kit. Start with the motor. It is a Sunny Sky 22 R2205 2300 kV. Quite a nice looking motor, this one, all silvery and shiny. It's about 34 grams in weight, and it is a counterclockwise threaded shaft. It's a standard 5mm shaft that you get on a lot of mini quad motors and so on. And I think it's quite a good decision to make it a counterclockwise thread, because I found that when I was looking for looking for propellers for my mini Talon a while ago, it seems like a lot of the props that are sold separately or as just one, they come with the intention of being stuck onto the front of the plane as a tractor configuration, in which case they're made to spin so that the nut on the propeller shaft will be a clockwise tightening nut. And when you turn that around and when you put it on the back to push a pusher configuration, you need to have it the other way around to stop the nut coming off. So this is better than having a clockwise motor for a flying wing with a pusher prop. In any case, it has quite a beefy looking nylon lock nut on here anyway, so it probably wouldn't matter even if it was a clockwise threaded nut. The ESC is one of these. It's branded as Reptile, 25 amp, rated at 4S. It says BL Heli, so that's interesting. Maybe it has the firmware that will stop the prop when you put the throttle to 0. That would be quite helpful. I'll check that in a minute to see what it does. I'll put it on my thrust test stand and we'll see if it's going to freewheel or spin when the throttle goes to 0 or not. It's quite small. Yeah, very small actually. You can see my thumb there. Let me just take the sticker off and see if we can have a look at it. I probably can't tell Oh shit, here we go. This is what is under the sticker. I'm pretty sure that says F396 on the little chip on the left, so it's a pretty capable microcontroller, Scilabs. And the fact that it said BL Heli on the sticker is a pretty good sign that it should be easily configurable if you did want to change the behavior that it comes with. This is probably a rebranded version of some other ESC, isn't it? I don't recognize it, but if anybody recognizes what this HGL thing is, maybe you can let us know in the comments. There are two of these 10cm servo extension cables, although I'm not sure why you'd need to use them because the cables that are on the servos already are easily long enough to reach into the fuselage. You get an XT60 connector and a couple of little bits of silicone wire for that. Unfortunately, there's no heat shrink, which I'm going to have to add myself because I don't want these terminals bumping around inside the fuselage next to this thing. And which brings us to this thing. What is this? I didn't realize that this was going to be part of the kit. And if you look at the listing for this thing, I did see this sort of red PCB up here, but it looks quite small in this picture and it doesn't really match the one that is actually in the kit. See what I mean? It looks very, very small. So I wasn't quite expecting to see this, although I did notice down here it says something about flight controller, 3-axis flight control, but they don't really play this up very much. I think they should probably mention it a bit more in the product listing. Anyway, so what do we have here? It's a board that sort of tries to bring everything together, a little bit like a power distribution board, and then it also sort of distributes the signals. These two here are the outgoing signals to your two servos. The ones on the left side are incoming signals from your receiver. This is the signal that's going to go out to the ESC. And we have a couple of power pads for the ESC, which I assume just take the voltage directly from these two pads here, which are coming in from the battery. And then over here on this daughter board kind of thing, which is sort of raised up above the main board, it's a little bit loose, this one. I'm kind of inclined to fix it down somehow before I go flying with it properly. But this is a 3-axis gyro stabilizing thingy, and you can see, let's see if we can look at this, not really sure. This is probably a gyro accelerometer there, and that would be a microcontroller of some kind. No idea what it is. Atmel. Oh, there we go. 168p. Yeah. Anyway, so we have some settings up there where we can choose delta, which is what we're going to use for this plane, VTail, or AL2. What is that? There's some reasonably good documentation for this, which I'll show you in a minute. So underneath this board there's a space for this little thingy, which is a 5-volt switching back, and you are supposed to solder that onto those pads and put it in the place provided to give you 5 volts for powering, I guess it's for powering this, and you can also power something else if you want to, because the 5-volt out has pads on this over here as well. And then there's another voltage out here. This is coming directly from the battery, so if you wanted to power a FPV transmitter or something, you could do that from here. So it's an interesting idea. I'm not sure that it's totally necessary. I tried one of these gyro stabilizer things in the past, and to be honest, I didn't really notice a huge difference from just flying normally with without the assistance. But if it has the ability to auto level, that could be helpful. Maybe if you have a fail-safe situation or something goes wrong and you don't want it to just crash, you might be able to let it hold level for a bit. That could be perhaps useful. So let's have a look at the documentation for this. I'll just give you a quick look at this. It's basically what I just said, so you can pause it if you want to have a look. But notice that there is a knob channel, which is also an aux channel switch that will let you say which mode of the flight controller that you want to use. So there are 3 flight modes supported. Not entirely sure what these mean at the moment, but rate mode I'm assuming will just try and hold the current attitude. Hold mode, I'm thinking this is actually an auto level, so I'm looking at 2B there. We'll see what happens, and then C will be just do nothing and let the ordinary controls go as they normally would. So there's some stuff there, and then makes sure that you know which. Where are we? Delta. This is what we want. So you set your switches like that. What else was I going to say? Oh yeah, it's quite nice the way they've organized the gain settings. It lets you set the magnitude of the gain and also the direction of the gain just by using those little pots on the top of the board there. And this is quite handy because I had a hell of a time setting up my other gyro stabilization thing when I was trying it in the last plane. I had one on a Tech Sumo, and I just couldn't get the elevons to go in the right direction and also be compensating for movement in the right direction as well. So hopefully this will solve that problem. And then there's just a little bit of info about making sure it's working the right way. The video transmitter is one of these fairly standard kind of things. Has 48 channels, so it looks like it can do race band. That's good. And it goes up to 24 volts, which is good as well. And you switch it using dip switches on the back. The camera is a bit of a generic looking thing as well. There's no facility for changing the settings. It's just got the ground and power and signal pins at the back. It's about the same size as a Runcam Swift sort of thing. It's got some info here which I'll just show you briefly. You can pause that and look at it in detail. I'm not expecting too much from this, to be honest. It's probably one of those older style CMOS cameras that weren't very good back in the day. I used those and I thought they were okay, but now that I've used the Runcam Swift, I don't think they're okay anymore really. So I'll probably be changing that camera for something else. But I will try it since it's part of the kit that was included. Now we've got some cables here for the camera. This is the one that fits into the plug there, and that goes into this, which is not very useful because we're going to have to power this from 12 volts as it says on there, DC 12 volts. I suspect it's probably not going to work at 5 volts, but maybe it will. So I'm guessing I'm going to have to use this battery out here to power it from there. And the wiring that you get for the VTX is this stuff here. It's just sort of a bunch of wires coming off this plug. So you're going to have to break out your soldering iron and set something up here to join up the blacks and the reds and the yellows on these to get it all working together and make a little bit of a wiring harness yourself, I think. So it's not exactly plug and play solution there. This is the other side of that sheet that I was looking at just before, which shows you how to set up the dip switches on your video transmitter to get the channels that you want. And it's looks like race band is frame 5, which is H, so you can get race band there. Very nice. Here's the other instruction sheet. This one is mainly about how to assemble the frame itself. Looks like they've got that old PCB design printed on the instructions still. So you know, it's pretty easy to assemble. There's not really anything that you need instructions for, to be honest. And on this side there's more of the same. This is the top side of it. What else? Okay, so down here we have some info. Just a couple of points. They're saying max 1800 mAh 3S, and I was wondering why they were saying that, because the ESC and the motor should both be able to handle 4S easily, and when I tried to put larger than this battery size into the battery bay, that was fine as well. So it's not a matter of battery size or battery voltage, it's so much as probably just a CG concern, I think. Maybe with a GoPro and an FPV cam up front, and then a battery any larger than this, and the CG is going to be upset. Perhaps that's why they put a max there. But this other max down here, max 6045 for prop, This is definitely a max for prop size, 6 inches, as large as you're going to be able to fit on at the back of the plane. So I've started into the build now. I have glued the main plate onto the back of the fuselage, and I Loctited these standoffs onto the screws before I attached it. I used epoxy glue to glue the carbon fibre to the plywood plate because I read on RC Groups somewhere that Gorilla Glue, which was what I was thinking to use, is not very good on carbon fibre. So hopefully this epoxy will do just nicely. And while I had the epoxy out, believe it or not, it's the first time in my life I've ever used epoxy. And I had one of these bottles that basically once you start using it, it's going to harden up and you can't use it again. It's quite annoying. So anyway, I went berserk with everything else that I could think of to glue on the wings. So there's the foam inserts here which make a round hole when they're stuck in. I wonder why they couldn't mould those. Maybe it's that would be a hard thing to mould, wouldn't it? So there's 2 of those. You have to get them right. One is a left and one is a right, for sure, especially at the front. These ones, if you get them wrong, they're not so bad, but the ones at the front definitely is going to stick out, make a huge unaerodynamic bump there if you get the wrong one in there. So I glued the spars in there and the spar at the bottom. Even glued the servo in with epoxy, just went berserk with the epoxy. And I also glued these in with epoxy too, and you can see I've cut the spar there to make a gap for this thing with no name. Yep, one of those. Because I want it to be right about there. I think that's a good spot to have it. Not sure if I would have cut that spar again if I was doing it next time, because it only saved me, if you look at it from left to right here, it only saved me about 2.5 millimeters. So it would have been 2.5 millimeters further to this side if I had to make it go around that spar. So I'm not sure if it was really necessary to cut the spar, but I think it'll be fine either way. And I glued these magnets in which had come undone. They had come undone on these ones, and then once I glued those in properly, then the ones at the top started to come undone as well. So it looks like I'm going to have to go around and do all of these again to make sure that these magnets are going to stay in there properly. It's a bit of a nuisance, but not too difficult. Yeah, this one I found I could just sort of pull this out with my fingernail without too much effort. So these definitely need to be done a bit better, I think. Come on. By the way, the problem that I had with one side of the magnets pulling out after I glued the other side in, that was kind of my fault because I was too impatient to wait for the epoxy to dry properly before I tried fitting the cover on. So I stuck the magnets to each other and left them like that for about an hour or so, and then of course the epoxy just sort of had seeped out the side a little bit, and the magnets had epoxied themselves together. So just a little tip to avoid that. It's pretty simple. Just put a piece of tape over the top like that, and I've actually gone around and smeared a little bit of epoxy around all of the other magnets that seemed like they were okay for now, and then put some tape over those as well, so you can maybe see the glue just sort of smeared a little bit around them. It looks a bit messy. So I shouldn't have any more problems from the magnets sticking to each other now, other than from magnetic attraction, of course. And the nice thing about this, having the tape there, is that you can actually now touch them quite freely to push that magnet in, make sure it's stuck in there properly. In the instructions they claim that this kit is, or the airframe is 170 grams without electronic equipment, but I found that to be not the case at all. It's I have the 2 servos in there and they're 9 grams each, so that's 18 grams. So we're looking at 209 grams with no electronic equipment, so that 170 is a bit of an exaggeration by the looks of it. This little piece of plywood was in the box too, and I thought it was a piece of an offcut of something that wasn't supposed to be included, but I've just realized what it's for, because these little tabs on the side of it match up exactly with those slots in the carbon fiber plate like that, and then the width of it matches up with this slot. You can see it goes down inside the foam block, and that's the exact same dimension as that. So it looks like this plywood plate is supposed to be inside there and sticking out through these little tabs. I'm not really sure why. It could be just to make sure that you've got everything centered correctly, but this carbon fiber plate, as you can see at the edges, it butts up against the sides of the foam insert area pretty precisely, so there's no way that you can really get it off center. And when I glued it down, I just held it, sort of squeezed it a bit like that with my fingers to make sure it was centered, and that seems to be good enough. I think I can't really see any reason why you'd want to use this, so I think I'll just forget about it. I just took this gyro stabilizer daughter board off, and I noticed on the back of it says Transtech NX3 revision 1, if that means anything to anyone. Okay, I have the XT60 attached now, and we're getting a nice 5 volts from here. Couldn't wish for more than that, really, could you? Oh, look at that, 5.000. Before I put the motor onto the plane, I did some testing with my thrust test stand, and I used these props here, which are the ones that I would feasibly be using on the plane. So there's a couple of 5-inch ones there and some 6-inch props there, and unfortunately I had some problems with this. I found that I couldn't reliably get any of the 6-inch props to go to full throttle at all, basically. The motor just seemed to desync, or the ESC seemed to desync at about 3/4 throttle, and I couldn't get past 3/4 throttle at all. These two here, this is just the regular plastic 5045 prop. That didn't have too much trouble. This is the King Kong 5045 bullnose, and this one would occasionally desync if you raise the throttle too quickly to get to full throttle. Up to 3/4 throttle it was fine, and then it was usually fine at up to full throttle as well. But these ones, no, just I don't think it's going to work. I'll show you a couple of clips from my testing, and you'll see why I settled on this one as the most likely to get the best power and also still remaining reliable. I began to suspect that there might be something wrong with that ESC, so I tried swapping the ESC for one of these, and it's not in here at the moment, it's over there on the test stand, and that works fine. No problems at all getting to full throttle with the 6-inch props, so I'm gonna say that there must be something wrong with this ESC. So here are the results of those tests. I'm looking at 3/4 throttle numbers because I couldn't get a proper number from full throttle for all of them, and you don't really fly around at full throttle anyway, so I think this is a reasonable number to look at. And you can see that the 6-inch props on 3S are giving us significantly more thrust and better efficiency as well. So I've just multiplied the grams per watt efficiency number by 100 so that we can get it on the same scale here. So I'll definitely try those. I probably will stay away from the 6045 bullnose. They sagged the battery voltage quite a lot. So I'll just use the normal 6045, and I'll probably also quite often use the normal 5045s on both 3S, and I'll try 4S as well. Just because I'm not sure. See, this is all done at static. The prop is not moving anywhere. When you're actually flying forward through the air, I think things might be a little bit different, but we'll see how it goes and see how much flight time I get from each of them. Before I glue the wings onto the fuselage and the winglets onto the wings, I wanted to find out whether the epoxy or the Gorilla Glue was going to be a better bond between these two foams. So I did a little test here, and I've cleaned up the surfaces with methylated spirits, which is otherwise called denatured alcohol, I think. I'm just going to try and break them apart now. Oh, okay. Well, that's the Gorilla Glue. Can we focus? There we go. Just peels right off like nothing happened. Useless. I did clean these surfaces. Okay, what about the epoxy? Okay, well this is winning already. Oh. No, look at that. It just comes off really clean. I wonder if methylated spirits is good enough to clean this surface off. I thought that's what we're supposed to use to do that. To clean off the releasing agent or whatever it is that they put on it to make it come out of the mold easily. Well, neither of those worked very well, did they? So I'm going to try this now. This is Gorilla Glue, and I've prepared the surface with the only other strong solvent I have around, which is gasoline. It seemed to make a visible difference to the surface, so I'm hoping that this is going to make a much better bond than it did before. I'm not testing epoxy now because my epoxy's glued itself together and I can't use it anymore. But let's see how this goes. That's better, I think. So it felt stronger, but it still pulled apart without too much difficulty. But it didn't sort of pull the glue away from the surface like the last piece did in a thin film, which is really terrible. This actually seemed to hold itself together fairly well, so this is about the best I can do, I think. So I'll just go with gasoline prepped surface and then Gorilla Glue. I'm going to do one more glue test, and I'm pretty sure this is going to work. In fact, I'm so sure it's going to work that I almost don't really need to do the test. Now, I don't know why I didn't think of this sooner, but I used sandpaper. You can see this one on the right. I've sandpapered off the surface, so now we know for sure that the release agent is all gone, and you can see it looks quite different from the one on the left, which I have not sandpapered yet. This is the one that I cleaned with gasoline, and it's still got a little bit of the Gorilla Glue on there from that test just before. But anyway, when you do that, you get a surface that looks and feels almost exactly like the surface that we have on the Texumo and the Bonsai, and I know for absolute certain that Gorilla Glue works very, very well on that. So that's what I'm going to do to stick the wings on and the winglets on. Okay, let's take a look at how that worked with Gorilla Glue. Looks like I've put more glue on than last time, but I didn't. It's about the same. It just seems to have squelched out the side more than before. Yeah, this is what we want, isn't it? I'm twisting this really hard. It's very elastic. Look at that. It almost bounced back to how it was. This is great stuff. Ah, there we go. Okay, so not really much to see there, but here we go. Well, now I can break it. That's interesting. But that's definitely a much better bond than what we had before. So, yeah, there we go. So that's what I'm going to go with. Sandpapered surface and then Gorilla Glue. So I glued the winglets on with Gorilla Glue, and that has worked very, very well. The winglets are actually sloped at about a 20 degree or so off the vertical, so it was a little bit hard to fix this in place while it was drying. This Gorilla Glue takes about 3 hours to dry properly. And on the Texumo and the Bonsai, it was actually quite easy to do this because the winglets are perfectly vertical, so you can just sort of put something on the wing and then put a block of wood up against it like that. But for this, to get it to stay in place, I've just used a bit of tape on each side like that as a bit of a securing mechanism to make sure it didn't move too much in either direction. And I've used too much glue, of course, but better than using not enough, I suppose. Just to compare this kind of EPP with the Texumo and the Bonsai type of EPP again, the winglets are very, very stiff. Like, I can move the whole wing like that and it feels like nothing is moving, whereas the ones on the Texumo are kind of soft and floppy. So that's I really like this new, I'm going to call it new type of EPP. It's new to me, but it's just, yeah, it's a very good material for planes, I think. As we saw in my test earlier, the Gorilla Glue does not stick very well at all to this surface unless you remove the surface release agent or whatever it's called. But one nice side effect of that is that when you're trying to remove these lumps from a glue seam like this, they don't stick to parts that you didn't want it to stick to. So it just sort of pulls off quite cleanly around the join. like this. I thought I was going to need a knife to get through this to cut it off, but for the most part you can just sort of pull it off with your fingernails, I think. So as far as attaching the electronics goes, I have some pictures here we can have a quick look at. That's the motor, obviously. ESC goes in that little bay there, quite nicely tucked in, fits perfectly, and the cover goes on like that. This is the one that had the missing screws, so I decided just to put a piece of strong tape across that, and that should hold it on quite nicely. This little piece of double-sided sticky tape came with the kit, and I'm pretty sure you're going to have to cut a hole to fit these pins in to fit it, to stick it down properly. And when you stick this in, the little cavity or cutout in this piece here fits perfectly over the hole which comes in from the ESC, and that's right where you connect your ESC signal and you solder on the power for the ESC as well. So if you put this board, it's just sitting there unstuck at the moment for this photo, but when I stuck it in I pushed it right up against this little butting up piece of foam and right up against the back wall, and that will keep it nice and square, because remember this has to be in the correct orientation in the plane, as it says here. Front has to be pointing towards the front of the plane like that. And I cut my wires about as short as you could get them, and that makes a very nice and tidy little connection to the ESC there. With the ESC signal wires were quite long, but you can pull them back into that cavity so that they don't waste space inside the main part of the fuselage. I stuck a JST connector on here. This is actually the wrong place. It's supposed to be on the battery one so that I can connect my video transmitter later, and I put it on 5 volts here, but don't worry, I've noticed that later and switched it over to this one. Underneath the gyro board I put a little earplug, because it sort of seemed like this corner of the board might be susceptible to vibrations in flight, and to stop it from sort of vibrating up and down I just thought this would be good to dampen it. The cable coming from the servo goes up like this, and it goes along here, and then it goes down like that, so it's sort of taking a longer than necessary route, and that ended up making it just a little bit too short to reach the connector that it needs to go to. So the two servos have to go here and here. It's very, very close. So I don't see why they need to do this, because even if you look at this other bay where you're going to have wires coming to, why couldn't you just bring the wire from, say, about here and just make it go zip in a straight line to here? You need to avoid this area because this is where the spar is, but there's no reason it needs to go all the way up here and all the way back down. So what I did was, I'll show you a little bit later, but I cut a channel from here to make it go directly to there, and we'll look at that a little bit later. So the little bay for your receiver or your video transmitter is about 37 by 26 millimeters, and it's 1 centimeter deep, 10 millimeters deep from this part to the floor. So it's pretty small, and I found that there was no way at all that the FSIA-6B is going to fit in there, even just by itself, or not even with this on. It's just not even going to work with that. Even taking the box off would not really help at all. So for this I decided to use the X6B, which does fit in there fairly well, but when you put this plug on you still have a bit of trouble squashing it in. It's going to be very, very tight. As we can see there, it doesn't quite fit in with that. You could probably jam it in, I think, if you wanted to, but at this point this just sort of became kind of a hassle, because you've got all these wires that you're going to have to bring back into the middle, and they're not quite long enough. They only come to about 3/4 of the way into the fuselage. So I thought I'd just put this inside the main part of the fuselage, because there was a little bit of space for it still, and that made things a whole lot easier. And it plugs onto the main board just here, so everything's nice and close, and the antennas are there, and just because of the way the antennas sort of ended up facing, it became easiest to put the rabbit ears thingy on the back. I wanted to put it here, but it wasn't going to work. The antennas just sort of, they didn't want to bend around that way, so it's ended up here with double-sided tape, and it's stuck on there very securely. Of course that means that the antennas are going to be blocking the cover, so I had to cut a little hole in the cover just to let the antennas come out. Because the X6B has battery voltage sensing telemetry capability, I soldered a little breadboard pin, what do you call these things? Never mind. I soldered that on there, and I switched the wires around on the connector for this. It's usually red, black, red, yellow, but for this we need to have it red and black on the outsides just so that it fits in there. So about those servo cable channels underneath the wings not being long enough to allow the cable to reach inside the fuselage far enough, this is what I decided to do about that. I had this hot wire foam cutter thingy set up from another project that in this case it was cutting about a 12mm square channel into the foam, and so I set that up to be very much smaller channel, just about 2 by 4mm or so, and this being a very short length of wire only required about 1.8 volts. Well, it's the current that's more important, I think. This is nichrome wire here, and it's about 1.6 amps or so, and that cut very slowly but it eventually cut a nice channel through the foam like this. And so I did that to bring what I was saying before about zip straight across like that from this point in the wings, so that the servo cable can reach inside quite nicely now. Okay, I have everything packed in here. It's a fairly close fit, but I wouldn't say it's tight or anything. You may be able to hear the servos moving a little bit. And they were set up correctly right from the beginning. I didn't have to adjust any of the gains or touch any of that stuff. All I did was on the flight controller I selected the delta option, and that's it. Make sure you plug the servo from this side into the plug on this side of the flight controller, and the one from this wing onto there, so they go into their respective sides. And then on the transmitter I have this set up as well. All I had to do here was reverse the roll channel ailerons set to reverse, and after that everything was fine. That's all I had to do to get it oriented correctly. And of course, if you want to select the different modes like auto level mode and so on, you'll also have to do one other thing. So presuming you're using one of these transmitters, of course, you'll also have to select aux channels, and I've put channel 5 onto switch C. So this is the 3-position switch here. So you'll need a 3-position switch to put that on. That's what I've chosen to use, and that will be the channel that you plug into the third plug on that side of the flight controller. So when the switch is off or up, and this will be the low position, 1000 microseconds pulse, you get gyro stabilization only. So I guess you could consider this to be like a rate mode if you're flying a multi-rotor. And when the switch goes into the middle position, you get nothing at all. And then when you put the switch all the way down, you get the auto level mode. So it has gyro stabilization as well, but it also has, I don't know if you can hear the servos twitching a little bit as I rotate it like this, but it's also going to set itself to level as well. But it's probably very hard to see what the servos are doing in the video, but trust me, it's all working correctly in the right directions, and I didn't have to mess with the gain settings on the flight controller at all. You'll notice when I have it in these different modes, there's an LED on there that changes behavior too. So it's off when you're in the middle. When you're in rate mode, it's just solid on, and then when you are in angle mode or auto level mode, it's flashing. A little bit hard to see, but it's flashing very quickly there. Actually, I spoke too soon about it not being tight inside that compartment, because I found that when I tried to put the cover on, it would fit on, but it would sort of bump up a little bit and wouldn't stay on very securely. And the reason was that this plastic piece of the strap is actually quite tall. It's probably about 5, maybe even 6 millimeters high. So I've had to put this underneath the bottom of the plane to get the lid to stay onto the compartment properly. And that's not very ideal because it only gives us a tiny little bit of Velcro to stick this to, so I might put a little bit of extra Velcro on here just to make sure that this tab is going to stay down like that and not easily come undone. So with all the components installed and with a 3S 2200 mAh battery on board, the all-up weight came to 513 grams, which is starting to get fairly high for a plane of this size. This is smaller than the Texumo, remember. And the CG is supposed to be right at the back of this little sort of jutting out bit that protects it when it lands. So right there is what they claim the CG should be. And when I tried this with nothing in the front, no camera, it just wasn't going to happen. But when I put my Xiaomi Yi in the front like this, all of a sudden the CG just went spot on right to that spot where it should be. Unfortunately though, this adds another 74 grams or so, so we're looking at 583 grams now, and when you pick this plane up and hold it, it feels heavier than you expect it to be. And here's a picture of all these planes side by side, and you can see they call it an 800 millimeter wingspan, and the Texumo's I think about a meter or 980 or something like that. But because these winglets slope outwards a little bit, it looks larger than it is. Well, it still looks fairly close to the Texumo, but the wing area overall is a fair bit smaller than the Texumo, so I'm guessing this plane is going to have to go fairly fast to keep in the air. To fix the Xiaomi Yi to the frame, I decided to use one of these camera tripod kind of screws that I had, and they fit into the hole in the bottom of the camera like that. So I poked a hole into the bottom of the camera bay with a hot wire like this, and that's looking at it from the bottom. Unfortunately, it didn't allow the screw to come through far enough to bite into the thread in the bottom of the camera, so I used my channel cutting hot wire thingy again to cut a sort of a circular channel around where the screw head goes on the bottom, and that allowed the screw to sit in. It actually sits in nice and flush with the surface now too, and that gives enough thread on the inside to hold the camera in just nicely. I added some of the stickers just to help me see which side is which while I'm flying, and that pretty much completes the build now. I think it is all ready to fly. Unfortunately though, the weather is not looking too friendly for the next couple of days, so I think it's probably going to be Saturday by the time I actually get to give it its maiden flight. So given that this video is getting quite long, I think I'll just upload it as is, and I'll make a sort of a part 2 with the actual flight of this when it stops raining. And well, it's actually wind, main problem at the moment. Anyway, we're almost about to hit the 1 hour mark here, so I really think it is time to stop. If there's anybody still out there, thank you so much for watching.